Okay, so we'll dive further into the inheritance issue. We talk about the very basics, just about how you can use the keyword extends and how you can use the keyword super. Okay, that's something you'll get a chance to practice in the lab. But I would like to go deeper into the subjects. Okay, we're going to see many interesting stuff today. And let's first of all do a little bit quick review of what we have done. Let's spend the first 10 minutes doing it, so just to set a context. So this is basically a summary of what we have achieved last time. We basically got 3 classes over here. That's the final design we have with the inheritance. Okay? We got 2 child classes over here, resident students and non-resident students. And also we got a super or parent class called students. Just make sure you got comfortable with the terminology. Okay? Also you called child classes or subclasses. Okay? Just different terminology. Okay. So let me review very quickly a number of issues, and then we can go further. Okay, point number 1. When you actually look at the Java code altogether, okay, I want to point out several things you want to pay attention to. Again, the source code has been made available to you. You can also play with it. Okay, it's highly recommended. Okay, so we have a student class over here, and then you can see that we define so many things over here. We define name, register courses, number of courses, and also some code for the constructor. And also we got register. We also got how to calculate the base amount for the get tuition, right? So these are all inherited to the child classes, okay, which extends the students. So that's why you will see that over here, for example, you can see in one of the child classes, let's say for students, you can see we don't have to declare register anymore, simply because register here implicitly will just be available to resident students. Okay, that's something to note. And there's another thing I want to mention. Every time when you want to create a child class, typically, I would say typically, number 1, you can declare new attributes or new methods sometimes, very often. And then, so this part here is interesting. Okay, let me draw your attention to it. I want you to first look at the student class. Okay, you can see this is the parent class, students, and we have the get tuition method over here, right? You can see that since we are trying to redeclare the get tuition method in the subclass called resident students. Okay, this class here and that class there. So now there is a terminology also you want to get familiar with. It's called overriding. Okay, let me just write it down. So over here you can say that the base version is inherited from students. However, we also try to further redefine that. And Java doesn't really use the term redefine. So redefine I thought is actually more meaningful to you, but they have a special term called override. Override. Okay, so you see sometimes I say redefine, sometimes I override. They can be used interchangeably. Okay, so now you can see that the way to redefine or override a method in the child class is by saying redeclare the header of the method. You can see the header looks just the same. It has to be the same. And then you can somehow use the super to actually say I want to call this particular version to start with. And then after that I simply say now I'm going to do something additional to it. Okay, that's redefine. Okay, that's about the coding part. Any questions? We okay? Okay, the use of super, the use of extends is really important. Okay, let's review another points. So now, given that we have this particular hierarchy, so you can see in the parent class, let me just, you can see I highlight every method and attribute in the student class using yellow. Okay, everyone. And then you can see somehow get tuition is mentioned again, but it's overridden. So I also put yellow. Yellow simply means those are the methods or attributes defined already in the parent class. Okay, and then I also put blue. The 2 blue methods over here, we got premium rates, and also we got set premium rates. So these are specific to the resident students class. Okay, only available there. And also the orange one over here, we got discount rate, we got set discount rates. So these are only available to non-resident students. Okay? So now, I want you to go a little bit from the bird's eye view over here. Every time when you have an inheritance hierarchy, you really want to distinguish between which are the inherited attributes or methods, like the yellow ones. Also, you want to see for each particular child class, which ones are like a new stuff, for example, the blue one here, and also the orange one here. Once you have seen that, you can now fill in the table over here. Okay? Basically, we talk about expectation. Expectation is really important. Okay? How do we decide, how do we determine the expectation? The answer is easy. You want to look at the so-called static type. How can you find a static type? Static type is simply the type you declare the variables to be. So every time when I try to declare S, RS, or NRS to the left-hand side of the assignments, I will put a type. So students is a static type for S. Resident students is the static type for RS, and non-resident students is a static type for NRS. Okay? So now we want to know, when I say, for example, over here, S over here versus RS versus NRS, what kind of expectation do I have? When I say expectation, I meant what method or attribute can you call using the dot notation after that context objects. Okay? The compiler follow a very simple rule. They only look at the static type. Okay? Later today, we'll talk about something called dynamic type. Don't get confused. Okay? So that's why I want to mention static type first. For example, you can see here, S over here, let me just use the right color to be precise. Okay, so now you can see, first of all, for S, we know that the static type is simply students. So that means everything that's declared or defined in the student class can be called by S, right? That's why the yellow part, you can see all of them are allowed. And similarly, you can see these methods or attributes can also be called by RS and NRS. Why? Because you can see resident students and non-resident students. So they are simply child classes of the students. So that's why they can also call the same yellow features, like a yellow methods. Okay, and then the next one to see would be the child class specific methods. For example, let's say for RS over here, resident students. You can see for resident students over here, what are new? Well, premium rates and set premium rates. So that's why for PR and set PR, you can see they are only available to the RS, whose static type is resident students. Okay, let's go a little bit symmetrically. What about the methods only available to non-resident students? So now you can see the orange one. You can see these are the two new methods we define in the non-resident student class. You can see those two are only available to be called by NRS, right? And NRS was declared to be non-resident students, okay? Static type. Any question about this table here? We kind of did that thoroughly last time. I want to make sure you understand that. This table is so important because later on, when we get to dynamic type, static type, and casting, many other issues, you always have to refer to this particular table, okay? And this table should be drawn every time you're given a particular inheritance hierarchy. For the student hierarchy, that's what you have. And also the handout you have, it's for the smartphone, but we'll get there, okay? A little bit later today. All right. Review another thing over here. How do we visualize the objects? That's also important, okay? So now let's see. So that's the hierarchy we have for the student classes. We already have gone through that. And also these are the three different static types, okay? So now when you try to visualize the object, that's how you can think of, okay? Let me just say something very quickly before we get there. You might be wondering if these are called static type, okay? All these three, they are called static types. What about dynamic types? Let me just tell you right away, okay? But I'll explain that a little bit further later. Whatever that goes after the new keyword, so these are so-called dynamic types. Okay, I'll write it down first. So they are simply called, so 1, 2, and 3 after the new keyword. Okay, so they are called dynamic type. So the tricky thing about inheritance is later on when you analyze programs using inheritance, you have to know when to use static type to analyze your program and when to use dynamic type to analyze your program. You have to know which context to use which. Okay. Anyway, so now let's say in the case of S, because it's actually a student's objects, so you can see when we visualize it, we just got only these attributes, right? So these are the ones from the student class. Okay? And you can see for resident student, which is a child class, they have at least as many things that's available over here because they're inherited. And also for non-resident students, you also got these. Okay? There's something additional to the child objects. For example, you can see that over here, because in the case of resident students, we got a new attribute, premium rates. That is why in the case of resident students, you also got premium rates. Okay? Only for the resident students. And similarly, if you got over here, let's say for non-resident students, the only thing that's new is discount rate. That is why when you see non-resident students, you got discount rate over here. Okay? So that kind of correspond to each other. Okay? So you want to go from the hierarchy over here, you should really feel comfortable to go from this hierarchy to this kind of visualization. Okay? That's something you would need to analyze your program. Any questions so far? Okay? If there's nothing you want to ask me about what we covered last time, let's review this particular one very quickly. Okay? We talk about polymorphism here. I will define that in just a moment, okay? A little bit later today. But whenever you see polymorphism, it says something about inheritance. Especially, it talks about assignments for variables. Assignments in context of inheritance. Okay, so now specifically, let's see this. We basically consider S of type students, RS of type resident students. Okay, let's visualize that very quickly. So now for S, it's now pointing to a students objects. Okay, I'll say S for students. And for students, we got the basic methods, the basic attribute. We got name, registered courses, and also number of courses. Name, registered courses, and number of courses. Okay, the details can be omitted just for the purpose of this. And then we got another one over here, RS. RS is pointing to a resident students object, right? How do we visualize that? First of all, it's a child object. It basically is an object of the child class. So it's going to be resident students over here. And then how many attributes do we have? We should contain at least everything that's in the parents, right? So we got name, we got registered courses, also we got number of courses. And what left? Premium rate, right? In the attributes, actually. Yeah, usually just include attributes. I'll write it down. Okay, in this case, I will simply put, okay, it's premium rates, okay? I'll say PR. It's a bit small, but anyway, I put a PR over there, okay? Now we got these two variables, S and RS. Okay, we were considering whether number 4 should be valid or number 5 should be valid. Okay? The answer is number 4 is valid. Number 5 is not. When I say not valid, simply means if you try this in Eclipse, it's not going to compile for line number 5. Okay? Let me try to explain to you once more quickly about how you can think of it, just in case you forget about the rule. Let's say this. Let's say we simply kind of prove by contradiction. I'll go over the process with you again because we kind of need to review the expectation. Let's say, assume line number 5 should compile. Okay? And then somehow, by following, if line number 5 can compile, that means we can go ahead and do the reassignments. And then somehow will lead to some crash. That's something we want to see. And that's why it shouldn't compile in the first place. Assume that line number 5 is going to compile. So that means we're going to execute this particular assignments over here. So that means we're going to reassign RS. And then assign that to wherever S is pointing to. Right? That's a reassignments. So that means we can execute, if that compiles, we can execute RS is assigned to S. So that's exactly what you're seeing, this reassignments. Okay? Everybody okay with this? So now, expectation is now important because you can see we kind of got some aliasing situation here. You can see the same student's objects over here is being pointed to by RS, for example. Okay? What's the expectation on RS? Let's be complete over here. Expectation on RS. So now, what should we look at? What type should we look at? Static type, right? So now, in order to see the expectation, we're going to see if you say RS dot, what should be valid over there? Okay? So you can see RS was declared to be resident student. So this is a static type, right? Always look at the declaration. So now what can you call? First of all, you can call everything that was inherited from the parents, right? So you can say rs.name, rs.register courses, rs.number of courses. So these are all fine. And notice that name exists in this particular objects. Number of courses also, registered courses also exist. Number of courses also exist. Everything's okay so far. Have we left out any expectation here? We have, right? Premium rates. Because premium rate over here is, let me write it PR, is specific to the resident students. So because RS was declared to be a resident student, so I should be able to say rs.pr. As I said before, when you have the dot notation, that simply means look up the address that is stored in RS and go to that particular memory location and then look for PR. Let's try that. If you follow whatever that is stored over here, we follow the pointer, we look at these objects. Do we have premium rates? We don't, because it's a student objects. So somehow we lead to some crash. It's actually possible. Okay? So now this will give us some crash. So line 5 should not compile. Okay, I'll give you a little bit more intuition, but make sure you're okay with this particular reasoning. This reasoning will be necessary for you to get some insight. Or sometimes if you really forget whether 4 or 5 should be really compiling, then you can try this reasoning. Okay, that will actually help you out. Okay. So now let's think about this. If you look at that, let's say this. Let me just recreate the example very quickly. If I have students over here, S is something over here, right? Also, I have resident students, RS is some expression over here. What's going to be valid is this. When I say S is assigned to RS, so this is valid, first of all. Let's see a little bit more. Why? Okay, everything's on the slide. You can also look at that. Okay, let's think about expectation. Let's be precise. The expectation for S would be name, register courses, and number of courses. That's it. We cannot call premium rates. We cannot call discount rate. Right? What about expectation here? Well, everything that is supported by students over here should also be supported by resident students. Agree? Everything. Okay? So now you got name, you got registered courses, you also got number of courses. And don't forget, you got something that's also specific to resident student. I can also have premium rates. So why is this valid? Somehow you can see the static type over here of RS, which is resident students, is a child class of the static type of S, which is students. I'll make it more precise for you. Think about the diagram here. We got students over here, and also we got resident students, we got non-resident students. Okay? Let's use some color to illustrate. You can see the static type for S is over here. Oh, actually, that's not good. Okay. Static type of S is here. And static type for RS is over here. Every time you're trying to do some assignment, think about the green and the blue. It will be a valid assignment if you're trying to assign blue to the green, such that the blue is a child class of the green for this particular example. But we're going to generalize it a little bit. Okay? Okay, so now over here you can see, okay, so this is actually a child class. So why is this safe? Why is this valid? The expectation we can call on S will only be the guys over here. Can they be fulfilled by some RS? Can they? Yes, because everything is available. Even though premium rate may not be used, that's okay. But the other way around is not good. When we try the other way around, like in the previous case, in that case, if you try to get access to PR, but it's actually not supported by students, that's not good. So we're trying the other way. Okay? We'll try to revisit this idea again, but any question for me? Okay? That's the most critical part to start with, actually. Everything builds on top of that. Okay. All right, let's go a little bit further, and then we can do a little bit more definition and exercises. Okay. Okay. Let's now do another important concept quickly. Okay. It's something called dynamic binding. Dynamic binding is actually interesting. So now, dynamic binding simply means runtime behavior depends on dynamic type. I'm going to illustrate that to you. Okay? Before I do anything to trace the code, I want to highlight the stuff you want to pay attention to. Okay? So now, line number 3, we declare RS, and then it's a resident student's objects. Line number 4, NRS is a non-resident student's object, right? Dynamically, they're different. They're pointing to different kind of objects. You can imagine that for this particular one, we got the premium rates. For this one over here, we got the discount rate, right? So they're different objects. Now, look at line number 7 and line number 8. You can see we are calling s.getTuition. Also, we are calling s.getTuition. These two lines are exactly the same. However, when you try to execute the code, it's going to give you different output. Okay, we're going to see why. As a preview, eventually what we will see is, at the point that we are trying to call s.getTuition over here, it is actually pointing to a resident student's objects. That is why it's going to call the getTuition from the resident students class, which will apply premium rates. At a later point, when we call exactly the same line, we wouldn't get the same behavior simply because at that point, S will be pointing to a non-resident student's objects, which we should apply for the discount rate. But let's see exactly how this happened. Okay? So dynamic binding is also very important. Let's try that. Okay, so now let's try to trace quickly. So now up to over here, okay, up to over here, we declare S over here. We got RS, we got NRS, RS, NRS, they have been drawn already. And we set a premium rate to be 1.25. We set the discount rate to be 0.75. Okay? And then we're also going to register both students to the same course. Okay? Let me draw that quickly. So this student is going to be registered for 2030, and this student is also going to be registered for 2030. The idea is when we try to calculate the tuition, and are we going to get the same answer? That's a question. But let's see. Let's see. Okay? So now let's see this. First of all, when we look at that, when we say S is assigned to RS, according to what we said in the previous slide, S is assigned to RS should be okay. Okay, we'll get to the rule a little bit later. Okay, if this is given that this is okay, what's the consequence of executing this? So that means S is now going to point to a resident student's objects. Okay, so now when we execute this line over here, when we say s.getTuition, dynamically S is pointing to this particular resident student. So that simply means at this point, dynamic type of S is resident students, first of all. Okay, depending on which object it is pointing to. So now when we say s.getTuition, we'll simply apply the premium rates. That's what we will do. In that case, we're simply going to get 500 times 1.25. Okay, you can do the math. Okay, just to show you, it's really going to calculate something here. Okay, it's a number, 125. Good. And then, oh, by the way, the fee of the course, just in case you get confused, I simply set 100 here. That is why you see 125, okay? Just make sure. And then let's say we do another line here. Let's say we do the one that's in green. When we say S is assigned to NRS, this is also going to be valid because on the left-hand side, S has fewer expectation than what's on the right-hand side, NRS. So you can satisfy that. That's not a problem. So now, given that this particular assignment is allowed, what we will do is S, rather than pointing to over here, S is now going to point to a non-resident student's objects. So this effectively does the following. It will change the dynamic type of the same variable S to NRS, which is here, non-resident students. So now, when you try to execute this line over here, when you say S.getTuition over here, now, if you look at the hierarchy over here, we basically got 3 versions of the getTuition. You can see version number 1 is over here, version number 2 is here, and version number 3 is here. So now, when we call getTuition over here, which version are we calling? Is it 1, or 2, or 3? 3, because it is currently actually pointing to a non-resident student's object. So you simply go to the corresponding class. So that's a version. In that case, we're going to apply the discount rate. In that case, you will simply calculate the amount. Okay? It's a different number. Okay? 125 versus 75. You can see exactly the same line, but executing in different points of your execution is going to be different, simply because the objects dynamically being pointed to are different. Dynamic types are different. Okay? Any questions? We okay? Yes? No, RS is equal, RS is under S is not valid. Yes, correct. So, are you talking about this example specifically or the previous one? Okay, they're different. They're different in the following sense. Previously, when you try to do this particular assignment over here, where it's RS is assigned to S, okay? This cannot be valid because if you allow it to happen, what's going to happen is RS will be pointing to a student's objects. That's what S is pointing to, right? That's aliasing. This will actually lead to a crash simply because RS, which was declared to be a resident student, you can actually call premium rates on resident students. In that case, premium rate doesn't exist, so that's why it will crash. Yeah. Yeah? Yes? S.PR? You mean in this example here? Okay. Yep, no problem. Let's see the next one. Good question. The question was, I'll write it down. Let's say everything just work according to this. Let's do one more line. Okay? If I try S.PR, does it compile? I heard no. Can somebody explain to me why S.PR wouldn't compile? Uh-huh.
We just have to create exceptions. So
You would, okay, you want to be a little bit careful with your explanation. I can't see what you mean. Okay, you're basically saying, okay, let me explain that. I know what you mean. You're on the right track, but just wrong terms. Okay, so S.PR is not going to compile because, first of all, look at the static type. Static type for S is students. And now, in order to see what you can call after the dot, you look at what is defined in that particular class and whatever that's inherited to it. In that case, the student class has no parents in this case, right? So you can see name and also registered courses and number of courses. These are the only 3. So now, can you say S.PR? No, PR is not part of it. Oh, okay. When you say S.getTuition, okay, first of all, we agree that S.PR wouldn't work. Agree? Good, very good. It's very interesting. I see exactly what you mean. Let me recreate it. Okay. Students S is assigned to, let's say, new students. And then we got resident students, RS, is assigned to new resident students. Okay? And of course, we can say RS does set premium rates, let's say to be 1.5. Okay? Let's see this. First of all, S.PR, as we agree, not going to compile, right? Very good. RS.PR, would it compile? Yes. Static type, that's supported. Good, very good. So far, we only talk about compilation. So far, okay? So now, when you want to see exactly what's going to be produced at the runtime, it's somehow beyond the capability of the compiler. So when the compiler says something will compile, what's going to happen might be more than what you can see from the code. Okay? What's going to happen is this. Okay? That's why every time you see some question from the test or when you're trying to do application, think about whether your concern is really about whether things should compile or how things work at the runtime. When you want to consider whether things compile or not on Eclipse, only look at static type, which is what we're doing here. If you want to analyze runtime behavior, like what I'm going to do now, you have to consider dynamic type as well. Okay, so now let's see. So now let's see this. If I do something like this, if I say S dot get tuition, okay, I'll put it here. And also I got S dot get tuition. Oh, actually, let me just write one more line. Let me use a different color here. Pink. Let's say S is assigned to RS. This one is valid, okay, as we explained. And now if I say S dot get tuition again, okay, let's say this is 1, this is 2, this is 3. 1 and 3 are exactly identical, okay? Your concern was, which version of the method are we calling? Okay, so now over here, S.getTuition over here, which version of the method is going to call? Let me just do that. Depends on what the dynamic type is, okay? So now again, let me bring into context the classes, okay? So that'll be even clearer. Remember the hierarchy here, we got S, students, we got resident students, also we got non-resident students, okay? Get tuition has one version over here, calculating the base rate. Get tuition over here has the second version where we apply the premium rates. Get tuition over here also get a third version where we apply the discount rate. We got 3 different versions of the get tuition method, 3, okay? To make it easier to see, let's say this is version 1. This is version 2. This is version 3, okay? When I try to execute this line over here, apparently I can call get tuition, but can you tell me at the runtime which version is it going to call? Is it going to be 1 or 2 or 3? I heard 1, okay? This one seems to be quite obvious, but before I go to the next one, this is how you should analyze. When I try to say S is assigned to a new student, that one's easy, right? S is now pointing to a students class. And when you put a title over here being students, because we got student after the new keyword. So that means it's a student object that's being pointed to, okay? So that's why when you say get tuition, because it's pointing to a student class, so you're calling version 1, okay? So now let's get to your point, okay? Let's consider the following. When I try to do number 2 over here, okay? I say S is assigned to RS, okay? Where's RS? RS is over here, okay? I'll draw it here. RS is basically pointing to some new resident students class, okay? I'll put RS. So dynamically, it's RS objects, resident students. And then we can set a premium rate. Somewhere premium rate is 1.5. Now, This line over here, as we discussed, this line over here should be allowed, it's valid. Let's execute that line. If we execute that line, that simply means S is not going to point to here anymore. Dynamically, it is going to point to this object over here, right? This object. So now, dynamically, S is now pointing to RS. Okay? So now, let me do one more line for you. After 2. Let me say 3.1 and 3.2. 3.2 and also 3.1. S dot premium rates, and also 3.2 S dot get tuition. Now, compilation-wise, should 3.1 compile? You would think that compile simply because S is actually pointing to some resident students object, right? That might be what you're thinking. Wrong. When you talk about compilation, you don't worry about what's being pointed to. You only look at the static type. That's it. Okay? So this not compile, simply because static type of S doesn't support it. And now, interestingly, when you try to execute this line, S.get tuition, is it going to execute version 1, version 2, or version 3? It's actually either 1 or 2. There's no non-resident student in this case. Either version 1 or version 2. Take your pick. Okay, so now when I ask you which version is going to be executed, execution is about runtime behavior. In this case, what should you consider? Dynamic type. Okay, so now this line over here, first of all, it compiles. Simply because the static type of S, which is students, supports that. That's about compilation. That's concern number 1. Okay, that's A. And for concern B, so now which version of get tuition is called? So now this is about runtime behavior. In that case, you want to look at dynamically, it is pointing to some resident students objects. So that means it's going to call that particular version. Okay? Because dynamic type of S is RS. So you will call the RS version, which is over here. So guys, let me summarize quickly for you. I know it's kind of tricky, but I hope that's just at least clear. Okay? So now, whenever you're answering questions or trying to think to yourself, think about whether there's a compilation issue you're trying to solve or a runtime issue you're trying to solve. If it's about compilation, the only thing you worry about is the static type, nothing else. That's kind of straightforward. And this is exactly how the Eclipse compiler was implemented. Okay? On the other hand, when you talk about which version of method will be called at the runtime, it's a runtime issue. In that case, you have to worry about dynamic type. Okay? That's something we'll keep emphasizing. Okay? Any questions? Yes, I'll take you first. Yeah.
Say inside the equation, we had we used a new method that wasn't existing.
Okay.
Did that work?
Okay.
So we define a new method in RS which doesn't exist in S. Would that method execute as well?
The answer is no. S over here, RS, let's say NRS, okay? Let's say statically, we say, okay, students, let's say S, okay? So static type for S is simply students, right? So now let's say this. We have get tuition over here, and also we got get tuition over here. Also, we got get tuition here. Let's say as you said, let's introduce a new method, set premium rate. How about that? Okay, set premium rates. This method is only specific to RS. Okay, so now let's try the following. Again, as before, RS is assigned to new resident students. And also you can say RS dot set premium rates. First of all, will this line compile? It will, because RS statically, as we declare, is resident students. It does support set premium rates. Okay, so now let's do the following. If I say S is assigned to RS, this will be allowed. Effectively, what's going to happen is S is now pointing to wherever RS is pointing to, which is a resident student's objects, which does support PR. Okay, so now let's try the following. Dynamically, RS is really pointing to, oh, sorry, not RS. Dynamically, S is really pointing to some resident students objects. If I say S dot set premium rates with 1.5, my intention is I want to modify this to 1.5, but that's my intention. So now the question is, should this line compile? Think about it. Should it compile? Should it compile? What should you look at? You only look at static type. Okay, in that case, what's the static type for S? Students. Does students support set premium rates? No. To make it even clearer for you, you can see S is pointing to the same object as RS. On the other hand, if I try to write RS dot set premium rates 2.7, should this compile? Guys, that's a very interesting bit over here. You can see, even though from your diagram here, S and RS, they're pointing to the same objects. However, they were declared slightly differently, right? Even though they point to the same objects. You can see over here, S was declared to be students. RS was declared to be resident students. So from the compiler's point of view, their expectations are just different. Even though they point to the same objects, there's certain limitation on that. So you might be worried about the compiler is so, the compiler is so unflexible. How many of you are taking 2001 right now? Quite a number of you, right? Have you guys heard about some word called undecidability? We'll get there today, a little bit. Okay. Anyway, my point is, if you think about these two lines, okay, the highlight would be think about these two lines. This will compile. Sorry, S.set premium rate will not compile simply because the static type doesn't support it. RS.set premium will compile because its static type supports it, even though they point to the same objects. Okay? It's very important to distinguish very clearly between runtime versus compile time. Very different. You call a method, you know what? That's getting a little bit complicated. Why don't you talk to me about that? Maybe I can present that to everybody. That'll be easier. Okay, no problem. All right, but don't worry, we'll revisit this over and over. So if you don't really get 100%, that's okay. Try as much as you can, okay? But it's important. Okay, so now after this, we'll talk about some new example here, but we'll keep revisiting the student class. So this slide here, if you look at the slides as well, we just talk about you may have different hierarchy for your class. Okay, before I get there, the slides you will see, it simply talks about in the inheritance, in the child class, what can you do? You can definitely declare, you can inherit everything from the parents, and also you can declare new things. You can also redefine or override the existing stuff. Okay, so that's already covered. How do you visualize your objects? I want to show you something here. Oh, that's something we covered as well last time. Okay. Let me just go directly to this diagram over here. Okay, polymorphism, dynamic binding, intuition, that's also covered. Okay, let me just go quickly. Okay, that's something we just talked about a moment ago. Okay, so that's just about whenever you want to deal with inheritance, it's not necessarily only got one parent and two children. It's very rare. Okay, it's very common. You may have multi-level. So that's just one example. So under students, you may have domestic versus foreign. Under domestic, you have either resident versus non-resident, and etc. Okay, that's one example. And the one I want to show you, which we're going to go over as well, is some like a smartphone example. If you haven't got a copy, maybe pick it up after class. Okay, I'll make it available as a PDF for you anyway. Let's go over very quickly, and then we're going to use that as we go for the rules. Let's say for now, okay, we have a class at the top. It's called smartphone. A smartphone can either be iOS or it can be Android. Okay, in the smartphone class, we try to define the minimum functions that should be supported by every smartphone. So we got dial, also we got surf web. Okay, so these are the basic, which means every smartphone we talk about, they should at least be able to, the expectation should be at least dial and surf web. Okay, so now let's go a little bit further. If we go for iOS, we are inheriting surf web, but somehow let's say default web browser in the iOS is Safari. Okay, it's a little bit different. It has been overridden. Okay, this one has been overridden. And at the same time, you can see in the Android, surf web is also a little bit different because default web browser may be Firefox. Okay, that's also overridden. Okay, and let's say in the case of iOS, we introduce something called FaceTime by default. There's an app. And then in the case of Android, we got Skype, just by default. And then by default, iOS doesn't support Skype. By default, Android doesn't support FaceTime. Okay, just say. And then under iOS, we also got, let's say, iPhone XS Max and also iPhone 11 Pro. And then for that particular model, for those of you who own it, they got something called Quick Take, for whatever meaning it is. Okay, simply means you can more quickly take videos, I believe. Anyway, that's a new feature. It's a new feature that's only available to iPhone 11 Pro, but not its sibling and not its ancestor. I mean the parents. Okay? And then let's say under Android, we got either Samsung or we got Huawei here, for example, right? And then we got different models over here. And now you can see, again, we got a new method over here for this particular model. That's called a zoomage. That's like somehow they apply AI to better take some, recognize human faces, something like that. Okay. And then under Samsung, you also got another two models over here. And let's say the common method they got is called side sync. Okay. Anyway, I just took some features from the web and then just create this hierarchy over here. But it's for illustration. What you should get now is, in this particular hierarchy here, we got not just between parents and children. It's more about ancestors versus descendants. It's more about this kind of relationship. That's something we want to get used to and see how we can extend our notion about polymorphism and dynamic binding in this kind of complex scenario, which is more realistic. Okay, that's something we're going to look at. Any question about this hierarchy over here? We okay? Oh, one more thing to say. Okay, every time when you see the diagram, when you have the arrow over here, so this simply means extends. Right? iOS extends smartphone. Okay, every arrow you see means that. Okay, so now we're going to go over some definition quickly with you. Okay, so now we're going to talk about general type hierarchy. So that one's a little bit dry. I'll try to use the example as we go along the way. Okay. So now again, we talk about data type, which is just be some runtime values, like objects, like object addresses. So now things get more complicated when you talk about inheritance. Okay. Implicitly, that's something you want to know. Okay. Remember, we talk about there is a class called objects in Java. Okay. You can think about implicitly any class that you define. For example, class A, or students or resident student. Implicitly, class A actually extends from objects, just implicitly. Okay? But you don't say that. You never say point extends objects. You never say that. Okay? Just implicitly. Okay? So that means whatever that's available in object, for example, equals, and also to string, they are automatically available to class A. And now this corresponds to how we talk about equals method, because The equals method in object class by default simply compare references. That version is directly inherited to A. If you want to have your own version of the equals, you got to override it, right? So it still corresponds to what we said before. Okay, good. Anyway, that's about object class. And then every time you got the upward arrow, that means extends. Okay, so now we have to first of all, it's transitive. What do I mean? If I say over here, C extends B, B extends A, implicitly I can say C extends A, right? It's almost like A larger than B, B larger than C. You know that, A larger than C, transitive, okay? Easy. And then we want to clarify these two concepts, ancestor versus descendants. Really important, okay? I'll use diagram to help you, and then we'll do one example together. So now let's say this. Let's say we talk about a particular class called A. What would be the ancestor? First of all, A is itself ancestor. And all its parents, their parents' parents, their parents' parents' parents, all the way to the top. So what do I mean? Look at this a little bit like a tree over here. That can be as complicated as things might go, okay? So now you can see that, first of all, what would be the ancestor? Ancestor of A, I'm going to use green to show you. You start with A. A's parents is here. Parents' parents is here. Go grab all the grand and grand-grand-grandparents all the way to the top. So this is so-called the ancestor path. So that's something we have to know when we do the casting, okay? So this is so-called ancestor path. Okay, are you okay with ancestor? Including itself and all its parents all the way to the top. Oh, any question? The top one as well, yes. I mean, over here, yeah, everything here. All the way, basically from A, you go all the way, follow the arrow until the top. That's ancestors, okay. Descendants just go the opposite direction. What would be descendants? Descendants simply say, let me show you. Let me use maybe a different color here. Let's say descendants. Descendants of A, the rule goes like this. First of all, A itself is also its descendants. So A is somehow its own ancestor and descendant at the same time, just for our definition. A itself and also all the classes that extends A. For example, you got this many children. And also, for all other classes which also extends their children. Basically, just go all the way down. Okay. It may be a little bit hard for you to imagine, but I'm just trying to show you the general case. We'll see some concrete example in just a moment. Okay. So now, let me go to some exercise for us. Let's go back to our smartphone example over here. Okay, let's do example. We're going to find out exactly what the ancestor, what the descendants, and what the expectations are for these three classes. And we can make some observation from that, which will help us. Okay? So let's try. So now let's focus on the green first. Let's see this guy here. Smartphone, okay? Smartphone here. What are the ancestors for smartphone? Smartphone itself, right? Good. Just itself. You can see that's the top already. Smartphone. What about the ancestor for Samsung? How many ancestors? 3. If you said 2, I believe you didn't count itself, right? You should. Okay? So that would be starting from Samsung over here, and then Android, and then smartphone. I'll say SP for smartphone. Okay? Let's do one more. What about the ancestor for, let's say, iPhone 11 Pro? How many ancestors? 3, okay. iPhone 11 Pro, iPhone 11 Pro, iOS, and also smartphone. Okay? Are we good so far? Okay. You know what? To make our life a little bit easier, can I just number the classes? Okay? So when I fill in the table. Let's say number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8, 9, 10, 11. Okay, so it's easier for us to refer to. All right. How about descendants? When we talk about smartphone here, how many descendants do we have? Okay. Would you agree? Basically, we're talking about when you want to figure out the descendants for smartphone. First of all, iOS and Android, they both extend smartphone, right? Also, these two classes also extends iOS, so they should be also descendants. And also, these two classes also extend Android, so they should be descendants as well. It goes basically recursively. So now, descendants will be from 1 until 11, everything. So what about descendants for Samsung? How many do we have? I heard 3. Okay, which 3? 7, 10, 11? Would you agree? Okay, basically you can see Samsung is over here, and then these two classes are the only one that extend from it. Okay, so only 7, 10, and 11. Okay, I'll mark it down. So you get 7, 10, and 11. Okay, what about the descendants for iPhone 11 Pro? How many descendants? 1. Don't say 0. Itself also counts. You always got at least 1 descendants, at least. Okay, that's very good. Hopefully you're comfortable with this kind of idea. Okay. Oh, sorry, not 11, 5. I beg your pardon. Okay, I should put 5 over here. Okay, sorry about that. So let's now talk about, yes, go ahead. Oh, very good question. So, okay, well, I would say strictly speaking, at least in my test, I wouldn't be so, okay, let me be precise. When you only talk about child classes, okay? When you talk about child classes, strictly speaking, let's say, what would be the child classes for smartphone? Only the level below, only that, okay? And then, if you talk about everything below, they are called descendants, not really child, okay? Yeah. But if I do ask you that, I will make sure it's clear in the context, yeah. Good. Okay, guys, the more interesting bit is about expectation. Okay, let's try that. I do want to draw some conclusion from that so you wouldn't get lost when you see the slides. So now, let me now think about expectation. Can we talk about expectation for smartphone? How many expectation do we have? 2, okay. Expectation for smartphone, which is over here. We got dial and surf web, right? Okay, I'll put it there. Dial and surf web. Okay, these two. And can you tell me the expectation for Samsung over here? How many expectation do we have? I heard 3, I heard 5. Anybody want aim for 4? 4? Okay. Let's see how exactly that can be figured out. Okay. The way you do it is by the following. Let's go backwards. First of all, let's go. Let's say, you know what? Let's go from the root. Basically, you can see Samsung is exactly over here. Okay. And then you can see if you follow the ancestor path, you can go all the way to the root. So that's where we start accumulating or start inheriting the methods. We definitely get dial and surf web for sure, right? So I would say dial and also surf web for sure. And now let's go down one level. And then surf web, you just overridden, so it's still there. We do have something that's new, Skype. Skype will also be inherited into Samsung, so that's also part of the expectation. So put Skype here as well. And then, in the case of Samsung, we also got a new method, right? It's not covered by my writing here, but it's side sync, right, on your paper, right? Side sync. So these are the 4. And any new methods, for example, n, you declare in the child class, they will not be part of the expectation for Samsung. Agree? Okay, anything that's new. Okay. Now, finally, can we work out the expectation for iPhone 11 Pro? How many expectation? 4? Okay, again, if you follow the ancestor path for iPhone 11 Pro all the way to the top, let's start from there. You got dial, you got surf web for sure. You got dial, you got surf web. And then from there, let's go back. And then you got FaceTime, right? So that one should be there. So FaceTime. And then in iPhone 11 Pro, we also got a new method called quick take, right? Okay, any question about the second column before I try to make a conclusion for you? Observation. Question, yes?
Can you just go over why is it not 5 expectations? Why are they not 5 and 4 for last two?
The last two, why would you think they will be 5?
Because let's say in Android, there's also, like, even though it's overwritten by
Oh, I see. When we say expectation, it's just about what methods can you call. It is true, we got one version of surf web in 1. We got another version of surf web in 3. But they're considered the same method, just different versions. So here we only talk about expectation, which is compile time phenomenon. Yes. Okay. All right. So guys, let's see this. If you have no question. Number 1, let me ask you the following. If you consider iPhone 11 Pro and Samsung, somehow they don't have the same parents. Agree? iOS versus Android. So they are not exactly sibling, but somehow they are cousin. Do they have a common ancestor? What is the closest common ancestor? Yeah, because if you just go up here, one level, they are not the same. If you go up one level, we merge. Okay? So smartphone over here is a common ancestor. Common ancestor of iPhone 11 Pro and Samsung. And what's so important about it? If you look at that, whatever that's defined in this particular common ancestor here, smartphone, you can see dial surf web, dial surf web, dial surf web. They are all there because they are common. They got the same ancestor. But that's it. Nothing else. You can see whatever that's left, for example, Skype and SiteSync. So these are very specific to this branch of the family, right? So they are not available for iPhone 11 Pro. They are not. Okay. Similarly, if you look at this side of the family, right? You can see over here you got FaceTime. You also got the Quick Take. So these are over here. They also have nothing to do with the other side. Any questions? Were you okay? All right. That one, again, just to give you some idea about ancestor versus descendants. Okay, let's go a little bit further. So now, when you actually see this particular sentence on the slides, whenever you talk about any class, okay, class A, they inherit all the code from their ancestor. So that is why when you talk about a particular class A is guaranteed to have more expectation than its ancestor. Okay, so what I mean is, if you look at that, if I talk about this particular class, let's say Android, if you compare the expectation of Android versus smartphone, which one has more expectation? Android, because it's lower in the hierarchy, got more code. On the other hand, if you compare Android versus Samsung, which one has more expectation, more method you can call? Samsung, because now Samsung is lower in the hierarchy, so they got more method for you to call. Okay, so that's exactly the method, the line over here I'm trying to say. Okay, every time when you are trying to look at a particular inheritance hierarchy, the lower you are in the hierarchy, the more methods you're going to inherit. So the more expectation you can have. The lower, the more. Okay, that's kind of the thing we will see very often. Okay, something similar for descendants as well. Okay. So now what I would like to do is to do a little bit of about static type. Okay, let's do that quickly. So now this slide is about whenever you see the static type, it really determines the expectation. Let's just do examples quickly. So now let's see here. So now I kind of put the two hierarchies together so you can see different example, right? You might be given different example in other scenario. Okay, let's see this. Let's say we focus on the student's case, okay? And that's the hierarchy we're talking about. Let's say I declare Jim to be of type students. So now, if I say Jim dot, what can I call? Again, static type is students exactly over here. You can basically call all the expectation on this particular class because that's already the top. So you only got name, registered courses, and number of courses, right? That's like a review, okay? So now, if you look at similarly, now if you look at the hierarchy for smartphones, okay? So now we declare my phone to be of type smartphone over here. And now, what can I call on my phone? For example, can I call site sync? I cannot, because static type is exactly over here. That's all you can call. Okay, I'll give you one exercise over here. Let's say this. If I say Android phone 1 is something over here, okay? And now, can I say P1 dot site sync? Can I do it? What's the static type for P1? Yeah, Android is exactly over here. Over there, do we have site sync? We don't. It only exists in the class below. Okay, so this will not compile. Okay, another one. Can I say P1 dot quick take? Can I do that? Well, again, right, for a similar reason, because quick take is actually over here. Nothing to do with Android, right? Okay. Anyway, that's about static type and expectation. Okay, okay, so this one is already covered, so you can just look at that. So over there, I just give more examples over there. We can just see that. So now we're going to define some rule, okay? Again, the slide can be a little bit dry, but we're going to just go over examples together with you. Okay, the slide itself simply talk about whenever you're trying to do variable assignments, V1 is assigned to V2. So when will V1 assigned to V2 valid? When will it be invalid? We have to see the inheritance hierarchy, okay? Let's go over examples together, okay? So now let's try that, okay? The rule is whenever you're trying to do assignment, let's say V1 is assigned to V2, okay? You want to make sure the static type of V2 versus the static type of V1. And this one here must be a descendant of. Okay, it must be. If it is not a descendant of that, then it should be invalid, which means it wouldn't compile. Okay, let's do examples. Let's see this. Let's say we declare these three variables. We got SP1, we got SP2, we got SP3. Okay? Before I annotate the diagram, should this guy here compile? SP1 is assigned to SP2. Think about what we're trying to do here. We're saying that whatever I expect on SP1, can it be fulfilled by SP2? Yes, exactly. That's how you can think of it. Okay, let's see diagrammatically how would that work. Think about static type for SP1 is iOS. And then static type for SP2 is this guy here. The pink is a descendant class of yellow, so that's fine. Okay? And you can do the same for SP1 is assigned to SP3, the same. Okay? So now, whenever you do this, let me just say one more thing to make a note for you. You're basically asking, can the static type of SP2 fulfill the expectations of the static type of SP1. Okay, SP1, SP2. Okay, that's how you can think of it. Now, these are valid cases. Let's see different cases. The same hierarchy here. Now, can I say SP1 is assigned to SP2? I have to redeclare them. Okay, it's a completely different example. Okay, should this be valid? So now, before I annotate the diagram, static type of SP1 is iOS. Static type of SP2 is smartphone. Can smartphone fulfill the expectation for iOS? No, because iOS, for example, is expecting FaceTime, which smartphone cannot support, right? Okay, diagrammatically, that's what you can do. If you think about it, SP1, the static type is iOS over here. And then SP2, the static type is smartphone over here. Is pink a descendant class of blue? No, it's ancestor, it's not descendants. So you wouldn't compile. Okay? Getting a feel? Okay, getting some feel. One more. Should this be valid? Anybody want to explain before I try to annotate? You want to try? Yeah, go ahead.
The static type for SP1 is iOS, and that's not supported by Hawaii, because that's
exactly. Let me just repeat what you said. It's exactly right. So SP1, the static type is iOS, which cannot be fulfilled for its expectation by the static type of SP2, which is Huawei. Agree? Okay, let's see that quickly. Okay, so now let me say, before I annotate, you can annotate the diagram as an exercise. So now the static type is iOS, and now the static type for this is Huawei. P30 Pro, and now this one cannot fulfill the expectation for that. Can I give you one example? What can be expected on this guy here over here that cannot be fulfilled by this? FaceTime? Yes, exactly. For example, so this is not going to compile because FaceTime, which is exactly over here, cannot be satisfied, cannot be fulfilled by Huawei. Okay, I'll put an arrow over here. All right, that's kind of the thing you want to get very natural, hopefully by the end of the semester. Okay, that's inheritance. Okay, we haven't got to the whole story, but we're getting part of it. Okay. All right, so now a little bit about visualization. Before we're going to talk about CAS very soon. Okay, before we talk about it, I want you to know that whenever you want to visualize objects, so now we talk about static type, we talk about dynamic type. Whenever you talk about it, you want to maybe try both. Okay, if I declare S to be of type students, and then I'm going to assign S to some new objects of type resident students. So now S student here is the static type, and after the new keyword, this is dynamic type. Okay, how do I visualize that? For dynamic type, it simply just be the title of the box where you draw, right? And then for static type, I would say just put the student over here, just right beside, just to remind yourself. Okay, that's a very quick note. So sometimes I may need to do it when I need to, but I would say typically if the static type is not so necessary, you can omit it if that's so clear to you. Okay. All right. So now let's see what else. Okay, for the rule of substitution, we talked about it already. Okay. It's being covered in the 3 examples we just went over, so I don't need to. But do read the slides before when you study. So let me finish the topic quickly about dynamic type. Okay, basically dynamic type, as we already covered, is simply going to be whatever objects that's being pointed to currently. So here's the rule: static type, once declared, can never be changed. Dynamic type can change always as you wish. Actually, your dynamic type should never stay stable. It should be changed throughout the course of your application. Okay, so now what I will do is I will show you, so there are two ways to change the dynamic type. Let's see both of them, okay? I got about 5 minutes. I'll see what I can do, okay? So we can talk about cast next time. So now, example 1. So now, how do we decide the dynamic type, okay? Basically, that's how you can think of it. So again, for Jim over here, students it's static type, okay? I will make a note over here. That's the static type. And then, whenever anything that's after the new keyword, so this is some potential dynamic type we want to assign, okay? So now, the way you think about whether this particular dynamic type should be allowed or not is to think about expectation, okay? Can resident students, the attempted dynamic type fulfill the expectation of Jim? And how is Jim's expectation defined? Static type, okay? Defined by static type students. Do you think you can fulfill? Yeah, because students only expect names, registered courses, number of courses. Of course, it can be fulfilled by resident students, right? So this is okay. So now, if this is okay, what's going to happen is, after this particular line, the first line, Jin declares statically as students, I'll put it here, is now going to point to some resident students object with premium rates dynamically. So at this moment here, after this, dynamic type of Jin is now resident students. Agree? After that. Now, let's try to do some reassignments over here. So now the same question. Can this particular proposed dynamic type, which is non-resident students, can it fulfill the expectation of students? Yes, right? So that's also fine. So what this will do is, after this reassignment, Jim, rather than pointing to over here, is now going to point to some non-resident students with discount rate. We are basically changing the dynamic type. So after this particular line, dynamic type of Jim is now NRS. What about static type? Does it ever change? No. Static type always remains the same. It's the dynamic type that might change. That's one way to change it. Okay? Let's see the second example very quickly. Example 2. So now, let's say this. Static type for Jeremy is resident students. And I'm simply just going to put it here. Resident student is a static type. I'm proposing to let Jeremy point to this particular student object dynamically. Do you think this might be valid? How do you think about it, right? Can students dynamically fulfill the expectation of resident students? No, you cannot. You cannot because students cannot fulfill expectation of resident students, which is the static type over here. Okay, you okay so far? Okay, I know it's quite a lot of information, but we want to get used to it, okay? Do you think I have 1 minute? Maybe? Okay, I'm pushing it by 1 minute. You know what, let's do this exercise maybe next week. Okay, I'll see you on Monday. Review this before Monday.